China has leapt from theory to practice, putting 14 futuristic bus and truck models into operation that are redefining global transportation. While Western markets continue to move slowly toward the transition to conventional electric vehicles, Chinese fleets are already running with cutting-edge technologies, autonomous trucks operating in mountainous mines, and heavy-duty freight vehicles capable of generating their own hydrogen in real time. These are not projections or concept models showcased at technology expos. These vehicles are already integrated into the country's infrastructure, challenging traditional concepts of logistics and traffic engineering. Stay with us to discover these incredible machines from the future. The first one will surprise you. Don't forget to like and subscribe to our channel. 14th, Transit Elevated Bus. Although the concept of the Transit Elevated Bus, TEB, appears to be a revolutionary solution for urban traffic congestion, an important historical clarification must be made. The project was abandoned in China in 2016. After initial testing with a prototype in Qinhuangdao, the vehicle revealed serious practical feasibility issues, such as its inability to pass beneath urban overpasses, its inability to accommodate vehicles exceeding height restrictions, and the traffic chaos it created at intersections, in addition to becoming involved in financial fraud investigations. Even so, the engineering concept was bold. An 8-yard-wide structure that used guide rails along the sides of the roadway to float, approximately 6.5 feet above traffic, carrying up to 1,200 passengers without interrupting the flow of vehicles beneath it. The promise was to eliminate the need to excavate expensive subway tunnels or construct elevated rail lines by utilizing the airspace above existing roadways. But if the engineering required to overcome urban congestion was already pushing the limits of logic, the next step in the evolution of Chinese transportation directly reshapes the energy sector and the way heavy trucks generate their own power. 13th, GAC Pickup 01. The GAC Pickup 01 exemplifies the impact of vehicle-to-home technology on the electric utility vehicle market. With an estimated range of approximately 350 miles under maximum load, the vehicle's greatest advantage lies not only in its mobility, but also in its ability to function as a rolling energy storage unit. Through its bidirectional charging system, the pickup breaks the traditional flow of energy consumption, allowing electricity stored in its batteries to power external grids. During power outages or periods of peak electricity pricing, the vehicle assumes the role of a high-capacity, silent residential generator, delivering enough power to sustain essential household appliances such as refrigerators and climate control systems, transforming vehicle ownership into an investment in household energy resilience. We are talking about 680 kilowatt-hours, enough to power an average home for 3 full days. But it gets even better. The truck bed features integrated solar panels. While the vehicle remains parked at a job site, it continues recovering range simply by sitting in the sunlight. And the regenerative braking system? Every time you drive downhill with a heavy load, part of that energy returns to the battery. The pickup literally recharges itself while you work. An intelligent load management system continuously monitors cargo weight and automatically adjusts power delivery. Heavy load, more torque. Light load, maximum efficiency. This is no longer just a pickup truck. It is a mobile energy platform that also happens to transport cargo. But China was not finished reinventing heavy transportation. 12th, Farazan H truck. What if a truck could produce its own fuel while driving? The Farazan H truck has turned that idea into reality. This is not an ordinary hydrogen-powered vehicle. Most hydrogen trucks depend on massive pressurized tanks and refueling stations that are still extremely rare. Farazan solved that problem in the most ingenious way possible. This truck carries liquid methanol, a common fuel that is easy to store and easy to transport. An onboard chemical reactor converts that methanol into hydrogen while the truck is moving. It is like having a miniature refinery installed inside the vehicle. The hydrogen flows directly into fuel cells that generate electricity. The electric motors deliver instant torque, and the only thing coming out of the exhaust is water vapor. Nothing else. The truck offers a range of approximately 620 miles, can be refueled in just 10 minutes, delivers performance comparable to a diesel truck, and matches its power output as well. All of this with zero emissions. There is no need for a hydrogen infrastructure or specialized fueling stations. Methanol can utilize existing fuel distribution systems, yet you still gain all the advantages of hydrogen-based energy. The fuel cells continuously generate 350 kilowatts, enough to haul 49 tons through mountain roads without difficulty. And because it is powered by electric motors, it provides the instant, smooth response that diesel engines simply cannot match. This truck is essentially a chemistry laboratory on wheels, cleaner than virtually any other vehicle on the road. But the next vehicle adopted a completely different approach to the refueling problem. 11th, Iveco Z Truck Zero Emissions Vision. What if a truck could drive itself while you catch up on paperwork? The Iveco Z Truck has turned that concept into reality. This is a fully electric freight truck with Level 3 autonomy integrated directly into its chassis. On highways, you can completely remove your hands from the steering wheel, and the truck drives itself. LiDAR creates a three-dimensional map of everything, up to approximately 650 feet ahead. Cameras read lane markings with millimeter-level precision. Radars track every surrounding vehicle in real time. Artificial intelligence processes all of this simultaneously and takes control of the driving task. The truck changes lanes automatically when it needs to pass slower traffic, maintains perfect spacing from vehicles ahead, and even adjusts its speed for upcoming curves before reaching them. But here is where things become even more impressive. These trucks communicate with one another. When multiple Iveco Z trucks are traveling on the same highway, they form automated platoons, 3 trucks traveling only about 33 feet apart in a tight formation. The lead truck's artificial intelligence coordinates the others. They accelerate together and brake together. The aerodynamic advantage generates energy savings of 15% for the trucks following behind. You are not simply purchasing an autonomous truck, you are acquiring a fleet that operates as a single organism. And the modular cargo system allows the entire body to be reconfigured in a matter of minutes. Different job? Different cargo requirements? No problem. No tools required. Just unlock, slide, lock, done. This truck has transformed long-haul transportation from an exhausting marathon into a supervisory role. But if you think a self-driving truck is impressive, wait until you see what happens when you give a bus the capacity of a train without installing a single rail. 10th, autonomous rapid rail transit. What if you could obtain the capacity of a train without building a single foot of track? This vehicle looks like a train, with 3 articulated sections connected together. But it travels on ordinary streets. No rails, no railroads. It follows virtual tracks. Sensors read lines painted on the pavement with inch-level precision, while artificial intelligence keeps the vehicle aligned with those lines, as though it were running on physical rails. You are watching something that weighs 40 tons, move through intersections, navigate curves, and operate autonomously in mixed traffic. 300 passengers, more than 4 fully loaded buses, combined into a single vehicle. LiDAR creates a 360-degree perception bubble around the entire vehicle. Cameras process lane markings and traffic signals. Radars track every car, every pedestrian, and every obstacle. The combination of all these sensors allows this system to see better than any human driver ever could, and it drives itself through mixed traffic, busy intersections, and rush hour conditions. Now comes the part that changes everything. Traditional light rail systems cost roughly $43 million per mile to build. Years of construction, roads torn apart, entire neighborhoods disrupted for months or even years. This system simply paints a few lines, deploys the vehicles, and enters operation within weeks. 1/5 of the cost, a fraction of the time, and a transportation capacity comparable to a train, moving autonomously through the city. Cities are installing miles of this system in the same amount of time it takes other places just to complete environmental studies for conventional rail projects. But China was not finished with autonomous technology. Ninth, XCMG ZNK 95. What if a truck could haul 95 tons without anyone inside it? XCMG has just made human drivers optional. Imagine a mining truck the size of a 2-story house, wheels taller than a grown man, and it is driving itself through a mountain mine without any human intervention. We are not talking about a prototype being tested under controlled conditions. These trucks already operate 24 hours a day in active mines, hauling 95 tons per trip. That means 190,000 pounds of rock and ore being moved completely autonomously. Here is how it works. 5th-generation wireless connectivity links the entire fleet together. Every truck knows exactly where all the others are. They coordinate routes, avoid collisions, and optimize traffic flow throughout the mine like a collective intelligence. The artificial intelligence navigation system plots routes around obstacles in real time. A rock in the way? It instantly recalculates. A steep incline ahead? It automatically adjusts torque and speed based on the exact weight it is carrying. And the sensors never get tired. They never lose focus. They never have a bad day. The truck constantly monitors its own mechanical condition. Predictive maintenance algorithms analyze every component. A bearing beginning to wear out? The system alerts maintenance crews before a failure occurs. A tire losing pressure? The problem is identified immediately. These trucks operate in conditions that no human would want to face: dust storms, extreme heat, the middle of the night. It does not matter. They simply keep working. 24 hours a day. No shift changes, no breaks, no accidents caused by fatigue. But if 95 tons sounds impressive, wait until you see how much the next vehicle can carry. 8th, XCMG XDE 440. 440 tons. Let me repeat that. 440 tons in a single load. The XCMG carries an amount of weight that seems impossible. That is 880,000 pounds. The equivalent of approximately 300 automobiles in a single trip. This is an ultra-heavy class mining truck, and it is redefining the meaning of extreme cargo transportation. The wheels alone stand approximately 12 feet tall. The dump body is so large that an entire house could fit inside it. And somehow, this giant moves. Here is the engineering brilliance behind it. It is a diesel-electric hybrid, but not in the way you might expect. The diesel engine does not directly drive the wheels. It generates electricity. That electricity powers individual electric motors in each wheel. And why is that important? Control. Every wheel receives exactly the amount of power it needs, based on terrain, load distribution, and available traction. When climbing a steep grade carrying 440 tons, the system adjusts power delivery to each wheel independently. If one side encounters loose gravel, that wheel receives different torque than the others. The dynamic suspension continuously monitors the load and makes adjustments in real time. Fully loaded while descending a slope, the suspension stiffens. Empty and climbing, it adapts automatically. And yes, it also features integrated autonomous capability. In open pit mines, these trucks operate without drivers, navigating haul roads, positioning themselves beneath excavators, unloading material, and coordinating everything through artificial intelligence fleet management systems. A single truck like this performs the work of 3 conventional 150-ton trucks. Think about the efficiency. Fewer vehicles, fewer operators, the same amount of material transported. But China was not only revolutionizing mining, it was also completely reinventing long-distance transportation. 7th, FAW hydrogen freightliner. What if you could cross an entire country while emitting nothing but water? The FAW hydrogen freightliner has made that possible. This is a heavy-duty tractor trailer with a gross vehicle weight of 49 tons. But instead of diesel, it uses hydrogen fuel cells. And the only thing coming out of the exhaust? Pure water vapor. Here is what makes it possible. Compressed hydrogen tanks operating at 700 bar. That is approximately 10,000 pounds per square inch. Storing hydrogen at that pressure allows the truck to carry enough fuel for a range of approximately 250 miles. The fuel cell stack continuously generates 350 kilowatts of power. That is enough to haul maximum loads through mountain roads without losing performance. And because the drivetrain is electric, you get instant torque response that diesel engines simply cannot match. Refueling? 15 minutes. Practically the same amount of time required to fuel a diesel truck. But here is the part that changes everything. This truck operates in extremely cold temperatures, negative 22 degrees Fahrenheit. Most fuel cells struggle in extreme cold. FAW developed a cold start system capable of bringing the truck to life even when everything around it is freezing. The thermal management system constantly keeps the fuel cells at their ideal operating temperature. Too cold? It heats them up. Too hot? It cools them down. All automatically. And ultracapacitors provide additional power during acceleration. The fuel cells deliver continuous energy, but when it is necessary to merge quickly onto a highway or climb a sudden grade, the ultracapacitors release additional power instantly. Silent acceleration, zero emissions, range and performance, comparable to a diesel truck. Long-distance freight transportation without emitting a single gram of pollution. But the next vehicle took electric public transportation to an absolutely absurd scale. Sixth, the Yutong U11 double-decker. What if a single bus could replace an entire fleet? It carries 200 passengers in a single vehicle. This giant is a true monster. 2 levels, 2 articulations, 4 connected sections, and it bends through corners. Imagine a bus longer than 2 articulated tractor trailers parked end to end. It turns by articulating at 3 separate points. Watching this vehicle move through city streets is like watching a mechanical serpent. But here is the impressive part. It is fully electric. It carries 550 kilowatt hours of battery capacity. That is roughly equivalent to 7 Tesla Model 3 vehicles combined into a single bus. And it needs that energy. After all, transporting 200 people, along with the weight of this enormous vehicle, requires tremendous power. The electric motors are distributed throughout all 4 sections, not just in the front. Each section receives its own power distribution to optimize traction and weight balance. When it accelerates, all sections push together. The regenerative braking system recovers energy from every wheel. Descending a hill with 200 passengers on board, the bus literally recharges its own batteries at every stop, during every deceleration. Energy flows back into the system. The range reaches approximately 320 miles, even when fully loaded and operating in real urban conditions, dealing with heavy traffic, constant acceleration, and frequent braking. The air suspension adjusts independently in each section. If one part of the vehicle hits a pothole, only that section absorbs the impact without affecting the others. The 200 passengers barely notice. And the pantograph fast charging system? A robotic arm automatically connects when the bus arrives at the depot. 80% charge in 40 minutes. One vehicle performing the work of multiple buses, silently, with 0 emissions. But autonomous technology was about to take freight transportation to a new level. Fifth, Inceptio Level 3 autonomous trucks. What if the truck could handle 90% of the driving while you simply supervise? Inceptio's Level 3 autonomous trucks have turned that into reality. This is the future of long-haul highway transportation happening right now. Level 3 autonomy means something very specific and revolutionary. On highways, the truck drives itself. Completely. You take your hands off the steering wheel, you take your feet off the pedals, and the artificial intelligence takes over everything. LiDAR creates a three-dimensional map of everything up to approximately 650 feet ahead. Every vehicle, every obstacle. The artificial intelligence predicts what other vehicles are going to do up to 5 seconds before it happens. It interprets brake lights, turn signals, lane positioning, and speed changes from surrounding traffic. Then it calculates their next moves before they even occur. That car 3 lanes over, signaling a lane change. The AI already knows it is moving into your lane and adjusts automatically. A truck ahead beginning to slow down? Your truck is already reacting before you even notice. Reaction time is just 1/10 of a second. A human takes roughly 1.5 seconds to react. The difference is enormous at highway speeds. And then there is the automated platooning system. 3 Inceptio trucks on the same highway connect through vehicle-to-vehicle communication. They travel just 33 feet apart at highway speed. The lead truck's artificial intelligence coordinates every movement. They accelerate together, brake together, change lanes together. The aerodynamic advantage of driving that closely? A 20% reduction in energy consumption for the trailing trucks? You are no longer watching 3 separate trucks. You are watching a single artificial intelligence-controlled organism moving freight. Automatic lane changes, highway merging, and traffic navigation are entirely managed by the system, while the driver simply supervises and intervenes in more complex situations. More than 1 million miles of autonomous driving have already been completed on highways, and the safety record is already outperforming that of human drivers. But China was not stopping at the highways. Fourth, BYD-8TT. What if a truck could position shipping containers with an accuracy of just 1 inch? It has turned autonomous precision operations into reality at some of the busiest ports in the world. This is an 8-wheel electric terminal tractor. But calling it merely a tractor does not do justice to what it is capable of. This machine independently repositions 40-foot containers throughout massive container yards. 4 independent motors, 1 for each axle group. That gives it a level of maneuverability that seems impossible for something of this size. It can practically pivot around its own axis, positioning itself with pinpoint precision. And here is why that matters so much. In a container port, space is everything. Containers stacked side by side, narrow lanes, trucks constantly moving. A single mistake can mean tons of steel colliding with extremely valuable cargo. But this truck does not make mistakes. An autonomous management system combines GPS, LiDAR, cameras, and ultra-wideband positioning technology to determine its exact location at all times. The result is positioning accuracy of just 1 inch, approaching a container for pickup, perfect alignment, positioning beneath a crane, exactly where it needs to be. No human operator can match that level of consistency. And it works 24 hours a day. No shifts, no breaks, no lunch hours. The port never stops. And neither does this truck. Its silent operation keeps noise-sensitive areas free from the roar of diesel engines. No vibration, no exhaust, just the faint hum of electric motors moving enormous loads. Predictive maintenance systems continuously monitor every component. A motor running slightly warmer than normal? Alert issued. Tire pressure dropping? Immediate notification. The truck schedules its own maintenance before a failure ever occurs. Ports using this technology report something remarkable. Container throughput increases by 30%, while cargo damage is reduced by 60%. But the most futuristic form of urban transportation was not happening on the ground. Third, Wuhan, suspended monorail. What if public transportation hung from the sky? Wuhan's suspended monorail has literally turned transportation upside down. This is not a train running on top of tracks. It is a train hanging beneath them, suspended in the air, gliding silently above the city while everything continues normally below. Imagine elevated guideways above city streets, but instead of the train riding on top, it hangs underneath. The entire passenger cabin remains suspended below the structure. And that changes everything for one simple reason: construction. Conventional elevated rail systems require massive structures, heavy tracks, and platforms capable of supporting enormous loads. It is an engineering nightmare. When the train hangs beneath the guideway, the structure can be simpler, lighter, and far less expensive. The system can be installed above existing streets without destroying roadways or disrupting traffic. Buildings do not need to be demolished. Roads remain open. Installation time is measured in weeks rather than years. The cabins carry 300 passengers and reach speeds of up to 40 miles per hour. A gyroscopic stabilization system keeps everything level during acceleration, braking, and turns. Passengers barely notice the movement. Magnetic braking eliminates brake pad wear and dramatically reduces maintenance requirements. And the system is fully autonomous. Sensors monitor guideway conditions while artificial intelligence controls speed, train spacing, and station stops. Everything is optimized in real time according to passenger demand. Capacity reaches 30,000 passengers per hour in each direction. Construction costs are only 1/4 of what is required for a traditional subway system. More than 30 miles of the system are already operating in Wuhan, while numerous cities are planning to deploy the same technology. Mass transit that can be installed in months costs a fraction of the alternatives and glides silently above the city. But the ultimate urban transportation solution was happening at street level. Second, Shenzhen Autonomous Bus System. What if every bus in a city operated as part of a single intelligent network? Shenzhen has turned that into reality with more than 50 autonomous buses coordinated as a single organism. We are not talking about one autonomous bus. We are talking about a central artificial intelligence managing transportation across an area of approximately 460 square miles in one of China's most densely populated cities. What makes this revolutionary is the communication between vehicles and infrastructure. Every bus communicates with every traffic signal, intersection, and traffic management system throughout the city. The buses do not simply follow routes. They negotiate with the infrastructure itself. A bus approaches an intersection and has already communicated with the traffic signal. The system automatically adjusts signal timing to create a continuous sequence of green lights. Not occasionally, every time. But it becomes even more impressive. Routing is dynamic. These buses no longer follow fixed schedules. The system monitors demand in real time, identifies where people are and where they want to go, and automatically adjusts routes accordingly. A neighborhood experiences a sudden increase in demand, more buses are dispatched immediately, an area becomes less active, vehicles are reassigned elsewhere. The artificial intelligence learns traffic patterns. Morning rush hour? It already knows where congestion will develop before it appears. A special event downtown? The system detected the crowd forming and dispatched additional buses 20 minutes in advance. Each vehicle possesses complete 360-degree awareness thanks to a combination of cameras, LiDAR, radar, and ultrasonic sensors. Pedestrians entering crosswalks, cyclists changing direction, cars unexpectedly pulling into traffic. The buses detect everything and react faster than any human operator. After more than 2 years of operation and millions of completed trips, the system has recorded 0 accidents. And there is an additional safety feature. Human operators can instantly assume remote control of any bus. So far, that has never been necessary, but the safeguard exists. This is not simply the evolution of vehicles. It is the evolution of the entire transportation network. but one vehicle represents the absolute peak of electric mass transportation. First, BYD K12A. At just over 88 feet in length, it holds the title of the largest electric bus on Earth. Its imposing structure consists of 3 articulated sections connected by 2 pivot points, allowing it to transport 250 passengers silently and efficiently. This giant operates like an enormous mechanical serpent in urban traffic, using distributed propulsion through 6 independent electric motors spread across its 3 sections. This architecture provides exceptional weight distribution, smooth acceleration, and outstanding stability through complex turns. Beneath the body, the vehicle carries a battery pack with a capacity of 680 kilowatt-hours, the equivalent of approximately 9 Tesla Model 3 vehicles, providing a range of roughly 320 miles even under traditional urban operating conditions with constant stops. The entire operating system is designed to maximize efficiency through a regenerative braking system that recovers kinetic energy from all wheels during deceleration, turning every braking event into continuous battery recharging. Passenger comfort is equally advanced. Independent suspension isolates impacts within each section, while intelligent climate control automatically adjusts air conditioning output according to passenger occupancy in each module. In addition, automated cooling and heating systems keep the battery cells at their ideal operating temperature, maximizing battery lifespan. By removing more than 150 cars from the road during every trip and operating without emissions or noise pollution, this fully electric bi-articulated bus redefines the efficiency of high-capacity mass transportation.